our home galaxy just got a bit more interesting. Astronomers announced the discovery of 3 new globular clusters at the heart of the Milky Way galaxy. Globular clusters are densely packed clusters of ancient stars that move around galaxies together. These cosmic systems containing millions of stars were formed about 13 to 15 billion years ago and are the oldest surviving stellar subsystems in galaxies. Since they are found in most galaxies, and since they've been around for so long, globular clusters have a lot to tell us about what the universe looks like now, and more importantly, how it got that way. After analyzing telescope images of the Milky Way and data gathered by NASA's Wide Field Infrared Survey Explorer, or WISE satellite, a Brazilian astronomer discovered 3 new globular clusters in the center of our Milky Way. These new globular clusters are in addition to 5 other globular clusters that were discovered last year. These globular clusters are between 12.5 and 13.5 billion years old, many formed just a few hundred million years after the Big Bang. During the early phases of our galaxy's development, the most abundant chemical elements were hydrogen and helium. As stars ignited and burned, they produced heavier metal elements, which were incorporated into later generations of stars. Because globular clusters are fairly metal deprived, researchers hypothesize that they formed very early on. The discovery of these new globular clusters could give us clues on the formation and evolution of our galaxy's innermost regions. These newly identified clusters, which are old and don't have many metals, also have the potential to improve our understanding of the structure as well as the kinematics of our galaxy. Home to millions of stars, globular clusters date back to the galaxy's early days and are very rare. So far, fewer than 200 globular clusters have been discovered in the Milky Way galaxy, the brightest and largest of which is Omega Centauri. Located nearly 16,000 light-years away in the Centaurus constellation, this massive star cluster is 150 light-years wide. Made up of nearly 10 million stars, Omega Centauri can be seen in the sky with the unaided eye and has been frequently scoured by Hubble. Globular clusters remain one of the biggest cosmic mysteries. They were once thought to consist of a single population of stars that all formed together. However, research has since shown that many of the Milky Way's globular clusters had far more complex formation histories and are made up of at least 2 distinct populations of stars. Globular clusters formed from giant molecular clouds, or huge masses of gas that form stars as they collapse. Because there is less free gas available now than at the beginning of the universe, globular clusters generally cannot form today. While you can see multiple generations of stars in globular clusters, what happens is the subsequent generations evolve from the first one. The first set of stars gobble up most of the gas, then, as they die millions of years later, they eject the gas. This means that the age difference between different star cluster generations is small, less than 1% of the globular cluster's age. The stars in globular clusters also tend to be smaller, since all of the large stars have either exploded as supernovas or shriveled into white dwarfs. Globular clusters also have high concentrations of red dwarfs, which are small, dim stars that can burn for billions of years. By researching and understanding these clusters, we can gain important insights into one of cosmology's biggest questions: what did the early universe look like?